one is in fact a double stand-in, because Paul was going to stand in for Loke. I'm now standing in for Paul. So there we are. Let's see how we get on. The title here is Implementing Positivity Constraints in 4D Resistivity Time-lapse Inversion. And the issue here was to, how do we use this 4D ERT inversion strategy when the changes in the model are only expected, or reasonably expected, in one direction. So imagine you have a situation where you can be fairly confident that your changes are only going to be towards the more conductive end. Actually, if you can, perhaps that's it. There's an example here of an irrigation experiment over this little sort of square array of electrodes there, and the first row is the baseline model, and the second row is a time-lapse, basically a 4D inversion of one of the time steps. And you see, if you click that again, please, there's some artifacts there which essentially represent infiltration of the solute into narrow fissures, and the fissures are clearly too small in relation to the electrode spacing. So you get these resistive artifacts in the 4D model, which are clearly not real. So the question was, how do we essentially encourage the 4D algorithm to account for those purely conductive changes better? So the way we implement that is we basically put a constraint on positive changes only. So we do a few iterations of a normal 4D temporally constrained inversion, and then the idea is to introduce a change of variables in such a way that only negative changes from the first time step are allowed henceforth. And you then follow that up by further iterations with that new, basically replaced variable. And so essentially that strategy removes the positive changes, and therefore you retain a similar misfit to the original inversion. The last row here is essentially the result of that. And you can see the 4D model is much improved over the second row there, and you end up with sort of conductive changes only. More details at the poster. So thanks very much.